Hello. Today our session is about DX APM Team Center. This session is about managing attributes and fundamentals. My name is Andreas Reiss. I'm working at Broadcom in the Enterprise Software Division for the APM part as a customer solution architect. Thank you very much for your interest in this session. And now we will go straight into one of the DX APM Team Center essentials. In this session, we will focus on the ATC map, the fundamentals, how it is built, what's working behind them, and how some best practices how to manage it. I know there are always questions in case you have questions for follow-ups, some more deep dive topics. Please leave a comment and we can work on these. Here you can see one of the maps, one you would see on your typical environment, which you bring up. This is an unstructured, at the moment unsorted map, and it's probably the starting point most of us face when we look at our environment. So the question is how to deal with it, what does it mean, what does it show, what can I do with this type of map? And in this presentation, I have some slides prepared for clarifications, guiding us through the presentation, but I will also jump into a live part on ATC, and we'll do some live examples here. In this session, we will focus first on the ATC vocabulary and elements. We will talk about the navigation ATC, about perspectives. I will introduce some of the map patterns, and in the end, once we discuss the map patterns, I will also discuss some best practices how to deal with these patterns. Let's go first into the ATC vocabulary and elements. In ATC, when we look at our map, at our topology, how application, infrastructure components, and potentially even more is organized, I'd like to introduce this vocabulary. It makes it easier following this session. So in this example, we have multiple different, you can call it nodes. We call it vertex, meaning essential transaction components in the map are called vertex. Once I group vertices, and we come to that point later, once I group vertices, I talk about the vertex group. Here you can see in the dark green, once this vertex group is collapsed, it's called vertex group, and a connection between vertices is called an edge. So an edge would be a communication. It could be a communication. It could be a relationship between components, but more to it later. ATC distinguishes between layers. What does it mean, layers? It's simply for us a way how to sort topological components of the application of the environment. So far, ATC distinguishes between three types of layers. One is the application layer. The application layer contains transactional data, meaning application components where we can uniquely identify a call path. And in this layer, we organize the elements by relationship. The infrastructure layer allows to organize resource components, how we call it. It could be resource, could be infrastructure component. In most cases, hosting or contributing to the transactional layer. And in the end, we have the APM infrastructure layer, where we have our internal cluster and APM agents organized. In ATC, when you are at the map view at the upper left corner, you will see the drop-down where you can choose the layer for observation. So you can toggle between the three layers: application layer, APM infrastructure layer, and infrastructure layer. These layers, how we organize the components, help us kind of at the multiple dimensional approach how to link these components, because only visualizing application components, like here for example a web service and the corresponding VM host, putting them on the same layer, it would cause soon confusion and would be very, very difficult to link, and especially on large environments would give us difficulties to differentiate between application components, infrastructure components. So here is one very, very simple example how you can imagine our link between layers. On the application layer, we have, for example, a web service. And on the infrastructure layer, we have a VM, which is running on the host. So this would be on the infrastructure layer. Now the edge contains relationship. The host contains multiple VMs. On the other hand, the VM does not necessarily need to know on which host it is running on. On the application layer, we talked about significant application transactional components. A significant component is typically, when we look at a classical transaction, the entry and the exit point on one thread, on one execution stack inside the system. So, for example, on a typical Java application, let's say we have a servlet, and down the stream, it would make a database call. In our mapping, we would represent this call stack as a servlet, showing a database, and the actual SQL statement call would be represented by an edge. The Vertex Groups grouping is achieved by using attributes. Attributes are components which are part of any vertex, meaning every vertex can have multiple types of attributes which we link. They are time sensitive, and we have similar sessions on new APM 11 features, Team Center features, where we also already explained the power and the magic of attributes. I will go in deeper into these attributes. For now, let's say we can give at every application, we can give an attribute, and these attributes can be set manually, by agent configuration, by dynamic based on the transactions, or by rules. So there are multiple ways. They are also documented, and in case there is interest, again, we can do a follow-up session how to set these attributes. I will go into some examples. So we group vertices by attributes, and in this example, I use, for example, an attribute with a key tier, like system tier or infrastructure tier, and one is presentation. On the upper right, we have data access, and the lower vertex group would be database. So this way, with common attributes, I can group components on the map. Next, before I go into some details, I want to talk about the navigation inside ATC. The whole navigation, the menus you will find in the ATC screen, are all built around the vertices. You know, in the history, in case you know APM for a long time, we had, in previous versions, we had the paradigm to have the navigation based on a selection in the metric tree. That changed completely. Now, this whole ATC map is organized to be context sensitive to vertex and vertex groups. Meaning, once I select a vertex, on the right side, I see selection-based information across layers, and I will come to that in detail in a minute. The bottom, once I select a vertex, I will get additional information related to this vertex, and that's also context sensitive. Normally, it would be an in-context browser selection, or it would be an in-context business transactions. So to demonstrate how this would look like in a real-world example, I'd like to switch to my screen. And what you can see here is a map, a typical environment. And once I click on one vertex inside the map, I will get detailed information, like this is, for example, a web service, and I will get additional in context, for example, metric browser information and business transaction information. And whenever I change to a new vertex, you'll see the tabs change, and I will get to this information in a minute. And also, again, in browser, in context information is changing. Back to our slide deck. So on managing these attributes and fundamentals, we have on the right side of the screen the component view. And this component view is separated into 4 areas. The first one is the name and the type of the vertex. Type means it's like a nature. For example, in case I have an entry point, like an application call, we would have the servlet of a servlet name and of the type servlet. The next section is the alert section, which shows us this specific selection. It could be a vertex or a vertex group. If I have active alerts on this and the alert state. The next section following is the metric section. Significant metrics are easily visualized there, and again, they are grouped by metrics or standalone. And the last section is all the attributes related to a specific vertex. So let's have a look into the details, how this looks in a real-world application. In a real-world application, let me switch here to the live mode. On a real-world application, once I click, for example, on an activity service, I see I have an inbound transaction, and in our case, it's part of the system. When I click on generic front end, I see the matrix related to this transactional component. So once I have my application, and now I have an application actively live running. What we just discussed on our presentation, I clicked on one component, which is for us an application entry point. Once I click on the component, I see the alert states, which are all on green. At the moment, we don't have errors, we don't have stalls. I can see the metric section, which visualizes the response time, errors, throughput, stalls, and individual attributes, details of this selected vertex. Like, for example, the container ID. So this vertex is running on a container. Or specific attributes I can set up front or by rules as discussed. Also on the metric browser, now since I have the transactions in live mode, once I click on the component, I see in context the individual metrics, and from there, of course, I can overlay these metrics, compare them, and look at the detailed data. The same applies to the business transaction. So these vertex also aligns as a filter for the business transaction. Now I have all the business transactions going through my token service, for example. And once I click on the user service, the same applies. Now I'm seeing all the transactions which are going through the user service, and from here I could select one transaction. Good. We see on the top the details So in our example, what I just selected as a user service is now of type Spring Service, and the name is user service import. Let's get this map organized. This is what this session is about, how to understand the layers, and how to deal with this larger type of map. For this, I'm going back to the slide deck. And our section is all about ATC perspectives. ATC perspectives help me to group the content of my map by individual attributes. Attributes, again, which I set up front, either automatically via API, via agents, configuration, or fully dynamic via rule set. The ultimate goal is to have a sketch, and this is normally what I do with customers. You have a high-level picture of an environment, and the ultimate goal should be to have this sketch really become your next dashboard. The power of ATC is don't waste time with static dashboards and painting. Make it dynamic, always up to date, and always in real time based on your current architecture in the system. The ultimate goal would be having your ATC perspective organized like this. And you can already see in this rough sketch, I would use, for example, application components like portal, utility service, mediation layer, or external services. And I will share with you some more best practices while we go live later back on my screen. Perspectives help me to create automated vertex groups. So in this scenario, we have always with an attribute on a vertex, we have a key and a value pair. Here an example, I have 3 vertices, and I have 3 types of keys, key A, key B, and key C. So I created for our abstract example a perspective which first sorts by key A, next sorts by key B, and third sorts by key C. So once I choose this perspective rule, ATC automatically creates vertex groups and names them after the key value. So for our example, the first vertex would be in a vertex group value X, the second value Y, and the last one value 3. So once I expand it, I would see the key B, and because the other ones didn't have a key C, I would have the last one key C. Meaning, when I create a perspective with key value pairs, and my vertex will not have this attribute key, it will simply ignore it. And this is how I can work with it, creating something like multiple layers to present my architecture. As a special feature in ATC, we can use attributes across layer. And now my example is getting a little bit more complex. Let's say we have on the application layer a web service A invoking a web service C. The web service A is running on host A, and the web service C is running on host B. In addition, of course, we have the APM infrastructure layer simply telling us agent A is hosting the information for web service A and maybe host A, and agent B for web service C and host. Once I start now organizing, I can leverage attributes across layers. So here, for example, on my hosts, I have a name attribute. And the first host is called X, and the second host is called Y. And I think you can already see where this one is going using attributes across layers. Now, I can leverage across all three layers to organize my map. So in this perspective, as you can see on the bottom, I first organized the APM infrastructure layer, which I use the attribute org. Second, I use on the infrastructure layer the host name, and last the application name. So this is something now when I look at the map in a fully collapsed mode, I would see org1 is calling org2. Expanding the next level, I would see name X is calling name Y. And only when I fully expanded, I would see the web services A calling web services B underneath. So for the next part, before I go into some map patterns, I want to do a special example with you, helping better understand how to read the matrix and how to see some details. And for this, I'm using a more abstract example. So this time we go back into the Marvel world, and I will share my screen. I used some attributes to create a special universe for our next scenario. And let me introduce you to Bruce Wayne, Clark Kent, and Peter Parker. In this example, you see we are on the application layer. Bruce Wayne is calling Clark Kent, is calling Peter Parker. On the infrastructure layer, you can see we have two cities. We have Gotham City and New York. And we have the Batmobile driving inside Gotham City, and we have the spider web in New York. Yeah, Superman is unfortunately without any transport. At the moment, as you can see, the infrastructure layer and the application layer are visualized independently. It's getting more interesting once I click, for example, on Bruce Wayne. So, as I told you, once I select one vertex, I'm getting in context my metric information. And to work on our scenario, I want to go a little back in time. And I will choose a time range from roughly an hour. As you might have noticed, and some of you maybe don't know, I can use the mouse wheel to navigate and scroll on the timeline and choose a timeline I'm interested in. So for our scenario, I will do this time frame, and I can zoom in a little bit more. As you might have already noticed, I have some dots here because I used attribute changes. So, coming back to Bruce Wayne, Clark Kent, and Peter Parker. We can see Bruce Wayne is of type Batman. So, on this right side, on the component view, I can see the relationship across layers. What I earlier illustrated, that there is behind the scenes a link between the layers, comes clear once I click on one of the vertices. So we have Batman. I know the corresponding agent, the monitoring agent where Batman is monitored with. I know of type city, we have Gotham City. And Batman is using the Batmobile. I can do the same game for Clark Kent. Clark Kent is of type Superman. I can see the agent and all the information it's running on. So when I click on Superman, I can see average life saved per day. So in average, he's saving 2 lives per day, while Peter Parker, for example, saves, I'm back to Spider-Man, average life saved per day is 1. So I can see here the statistics across the layers. Clicking on the city, I can see the crime rate index for New York. And clicking on Spiderweb, I can see his speed. So he is currently going with 30 kilometers per hour, while Clark Kent has no transport, but Bruce Wayne in his Batmobile is going 255 kilometers per hour. So how does it help me now having this information across the layer? Because certainly on a large environment, let's say, for example, I have a web service with a response time, but at the same time, I want to see on a container what is its memory consumption, CPU utilization, thread information. And it's impossible to click back and forth. So I can use now common attributes across the layers. And for this, I want to show you the example. One of the examples would be organizing a perspective, for example, by location and transport. And for this perspective, I use the city name as my first grouping and the transport as my second grouping from the infrastructure layer. So again, I'm pulling in information when I exchange to our infrastructure layer. We have the transport. Again, here I can see that Batmobile is only used by Batman, and the Spiderweb is only used by Spider-Man. Moving back to our application layer, now I select the perspective Heroes Location Transport. Once I go into my first Vertex group, I group now by a common attribute, and that's by city from the infrastructure layer. And instantly, once, for example, I click on Gotham City, I can see now the summarized metrics. So here, clicking on city, it's the crime rate. And once I click in New York, it's getting more interesting, because in New York, I have Clark Kent and Peter Parker. So once I click on the Vertex Group for New York, I see the crime rate index on the city tab. But more interesting on the application layer, now I can see underneath we have Clark Kent and Peter Parker, and it's building an average of the average life saves per day, and also an average about the rent paid. Meaning, I can use Vertex Groups for dynamically aggregating the metrics I'm seeing and to easily create a grouping or a combination. I'm frequently getting the question, what would be the easiest way to see the response time of a complete cluster? Well, you would use attributes. And you can use attributes like, for example, Kubernetes cluster name to organize it the same way. And I will come to that in a minute. So now I use for the first grouping, I use the city name. And for the second grouping, as you have seen in my Vertex group, I use the transport. So Clark Kent doesn't have a transport, but here we have space car and the web net. And once I expand it, I have the third layer. So here you can see the full map expanded, and just for you to see the definition again, we have city name and transport from the infrastructure layer as grouping. Attributes allow me to do even more. Bruce Wayne has a certain activity level. And on this activity level, I have created another perspective, and I called this activity level is now bored. So they are bored because there's not much to do, not much threat, not much life saving. Now, after a while, I change this attribute, and this could be fully automatic, even triggered externally or by your application. And you can already see here we have an attribute change on the timeline. So I'm now moving the timeline over this attribute change, and my map updated. So at this point in time, you see Bruce Wayne, he moved from bored to busy saving the world. So what happened here in the meantime is this attribute from Bruce Wayne, my activity level, is now busy saving the world, while the activity level on Clark Kent and Peter Parker is still bored. As you can see, these activities, these are time sensitive. I have to do a browser refresh on my connection. So you can see again the difference. I'm before the attribute change, they are all bored. And once I move this over, the activity level is now busy saving the world and bored activity level. Of course, I can use the same thing on the infrastructure layer. So on the infrastructure layer, I can create a new perspective and say infrastructure by activity. And this would apply to the APM infrastructure. But this time, I'm grouping my infrastructure by activity level from the application layer. So I choose the application layer, and there you will see my activity level for my heroes. Save. Now I'm choosing my new perspective. Oh, sorry. Infrastructure layer, I chose the APM infrastructure. Activities for resources. And I choose the application layer, activity level, save. And here's what you can see, that in Gotham City, the Batmobile is busy saving the world because Batman was busy saving the world, and New York and Spiderweb, everybody is bored, nothing to do. Once I click on Gotham City, again I see it is linked to Batman, the same, it is linked to Batmobile. So coming back to our real world example, before I jump into our application, I go back to the application layer. And on the application layer, we already have some predefined perspectives. One very valuable perspective, but which only focuses on the application layer, is a grouping by end user and application. This helps us in the first step to group by an application. An application is simply the name of an entry point. So here, for example, I can see an activity service, token service, client data engine, or a KIX transaction. But for our scenario, and I will move for this purpose back to our live mode because my application is running actively, I can also leverage the infrastructure. So we have some predefined perspectives, and here, for example, I could use host object, Kubernetes object. Let's have a look in detail what's happening here. I'm grouping by host from the infrastructure layer and by Kubernetes cluster from the resource layer. So now I can see that my map got already a little bit better by grouping host information. And now I have my 3 major hosts identified on the map, as you would see on the infrastructure layer. Moving back to the application layer, the next level, I can organize it on the resource layer, and let me follow with this map in detail. And for this purpose, I will modify this perspective slightly. So next, I will go to the infrastructure layer, and I can use another attribute, and you see the list is automatically populated. So, for example, I can use node name as a second layer. So once I expand now my hosts, it is now grouped by the node name on the Kubernetes cluster. And again, I click on this component and I can see this is my Kubernetes. On the application layer, underneath I have 3 components. It's running on AWS EC2. This is my Kubernetes instance with the performance data. And once I expand it, I can see the components, the application components running inside this Kubernetes. This map looks now only a little bit more structured, but still not good enough for our purpose. And before we go on some hands-on and doing more details, I'd like to switch back to our presentation to show you some best practices and patterns we have recently seen. The ATC map patterns, the first pattern is very, very common, and I call it simply butterfly pattern. Very, very common, and usually it could be much, much more. You see many, many entry points, maybe 1 or 2 nodes in the middle, and many, many exit points. So when you open the map unstructured, the first thing you're going to see is that it's huge and you won't be able to visualize anything. This is the first type of pattern. Huge amount of entry points feeding into one vertex and many backend systems. The next pattern, I call it cross pattern. It looks like a cross, and it's a kind of the contrary to the butterfly pattern. You have one entry point, many, many nodes in the middle, and one exit point. What would be a typical example for this one? Well, it could be, for example, one message queue, then individual application actions. It could be another servlet or URL invoked out of a JMS transaction, and everything calling one database. That would be one example for the typical cross pattern, meaning one common entry and exit point, large amount of similar application elements. And also, unfortunately, a very, very common pattern would be the island pattern, meaning you have many, many small islands and so many that it's very difficult to get a good understanding of your environment because it's not one end-to-end left-to-right flow. Application elements are independent, no common entry or exit point. And last, I call it broken tree. Broken tree because you see the leaves going. Maybe you do know they belong together. That's what I marked here in the green lines. But they are not connected in ATC. That could have multiple reasons. One reason could be that we were not able, for maybe technical purpose, or for example, an agent was missing in the middle, part of the application not monitored. It would show you the map, the transaction disconnected. You do know that these components should be connected, but for any reason, again, technical limitations, monitoring reasons, visibility reasons, maybe agent was not working yet, not deployed, you see the map disconnected. These are the most common problem patterns I identified so far. And again, when you give feedback to this presentation, I'm very, very happy to get more details or even more patterns from you, even with maybe screenshots or examples, so we can make a good collection on this. Yeah, we identified the pattern, how to work with these. And for this, I added a small section on best practices. Most important is, again, using attributes. Multiple attribute keys for as many layers as needed. There is no restriction. You can put as many attributes on a vertex as you want. As you have seen, the attributes on Batman, on Spider-Man, I can add as many attributes. These attributes can come fully automated by rules, can come manually, and can come even to the agent. So for example, at startup, you can tell your agent, please put in an attribute like org unit and give it my organizational information or an owner of this application. Best practices is to group by technology or target entry points, maybe URL fragments. So you can use regular expression to extract components of a name and use it as an attribute. And I will show you some examples in a minute on our live environment. And in case you have very, very many different outbound systems, or for example, like socket calls, like calls to IP addresses, use a number scheme, meaning outbound backend systems A, outbound backend systems B, sorting them alphabetically. Or you can group by IP addresses, subnet, ranges, for example. Another best practice is to how to deal with many disconnected nodes. You have seen the island pattern or the broken tree pattern, meaning with Vertex Groups, I can make the full group appear like nodes would be connected. Even ATC doesn't visualize them connected. And that would make sense if you want to have summary metrics, if you want to combine information into one metric, or later on dashboards, or for selecting it on alert status. Even they are not connected. And you can use attributes to put them into a common Vertex group. Let's get back to our map and do some real-world work on how to organize the map better. And typically, once I look at the map, I look where do I have many things which I need to organize first. And for this scenario, I selected a demo environment where I have multiple patterns. So here, for example, you can see a part of the butterfly pattern. One node, many exit points, many downstream calls. Here, for example, I have an island pattern, disconnected nodes. And also, we have another part on the butterfly pattern. And here in the middle, we could even say it almost looks like a cross pattern. But this is more similar. So let's start with the grouping. I have several outgoing calls here to Kix regions. And the first thing what I would do on my custom perspective is grouping, for example, by technologies. So let's have a look at the Kix region here. And what attributes can I leverage? So let's create a new attribute, and I call it, for example, environment. And I put as a value mainframe. Now you see I have a new attribute defined on my Kix region, which I earlier selected. Key environment value mainframe. The same I can do fully automated with attribute rule. I go into my attributes and I create a new rule. And the rule was environment. The new assigned value is mainframe. And I do this in case in my name contains Kix region. I have two matches, and of course now I need the other part, duplicate. So I have environment distributed, where name doesn't contain Kix region. And you see we already modified these components. So now when I start on my perspective, let's create a new perspective. Demo environment, application, and let me first group by now our new attributes, environment. And I like the approach we had earlier that we used from the infrastructure layer, the host name. And also the Kubernetes information from our infrastructure layer, giving us a good idea. So let's use the pod name, save. So we can see in our scenario, distributed is communicating with mainframe, and well, sometimes we have to get responses back, so mainframe is communicating with distributed. But now we have only a single box, and yeah, now we have to deal with what's inside. The Kix region is now separate, and that helps us a lot, because once I click on mainframe, I can see the summarized response times for all transactions on the mainframe. So it's like a metric grouping. Okay, let's go to the next step. We have some generic backends here. And we have here everywhere JMS outgoing. So my next rule would be attributes, communication, and my value would be messaging let's just call it communication, transport. My next would be messaging. Whenever I have in the name contains something with JMS. So you see where this is going. We go to our demo environment, and of course the next attribute rule which I'm adding, the next layer, would be transport. Save. So now you can see my next Vertex group, messaging transport. Okay, for the next, where do we have the next big block of things we want to organize? And immediately I can see I want to do something here on this part before, because these web servers should be first grouped into one, because normally I'm very much interested in the states, and I could use the application tier for this. And this time I'm not creating a rule. I could create a rule, but I simply enter it manually. So application tier is web server. This one would be also web server. This would be identical web server. And you already know what's coming next. I would use, for grouping on the application layer, my tier. Save. Okay. Well, now once we go into our mobile data and our URLs on the system, I will use also for simplification, I will use something to organize my end user requests. So, request type, mobile, and this one is also request type mobile. Well, these two are request type web, and this one identical request type web. Yeah, I had a small typo, but for our scenario it doesn't matter. And ideally, I like more the request type being outside of the environment grouping, and this is why I would like to restructure it a little bit. Let's start first with the request type. So first I go on the application components. I choose request type. Next, I still stick to my application level environment. Now I would come the host object again, because I think the host grouping is very, very important. Next, I would go for my application. Yeah, let's take the Kubernetes. Let's leave the Kubernetes in. Why not? Node name. Okay. And not to forget on the application layer, our transport and the application tier. Save. We are getting better. So we have the mobile requests going into distributed, the web requests going into distributed. Once I expand, it's getting a little bit better, but not really where I wanted to. And once I move towards, and again, normally I would create an automated rule, meaning in case I have a certain type of transaction, I say this is a web request. And now I can immediately see I missed, for example, some of the transactions. So here we have an application which is not going through one of our monitored web servers. So here, for example, I would do identically say this is from web. And the same way this one here. This entry point is also coming from web. Good. In the next step, I always prefer having, as you can see, the inbound and the outbound calls separated. And the next step I would do is identical to what I have done for the mainframe environment, for the outbound calls, for example, I would do for the database, and the same thing what you have seen on the JMS part. Okay. Now I can see that some of the communication is inside the host. To see the combination outside of this Vertex group, I would to reorganize my environment. So as you can see, the host object comes first, and later the transport and the tier. I will swap for my scenario, I will swap the transport and the tier and the host object. So here, for example, I will now use first my transport. Then I use the host. Again, my Kubernetes. And last, the tier. The tier is fine being the last one because I want to see it nested inside the other nodes. And again, you're doing this only once or a few times on your perspectives. And in the next step, once I collapse, you can see already we are getting closer on, we have the mobile requests, web requests, we have the distributed environment, and once I have the distributed environment, I can see messaging calls going out of the system, and it's not really super correct, but let me combine the databases and the other backends also into a transport so you can easily see where we are going with this grouping. So this is now transport. Text communication. here we have another transport. Kicks communication. Then I will use the tier attribute for the database. Once I collapse the nodes, you already see that things are getting now easier to understand. And here we have also a tier, another database. I have some more application components, and web service would be ideally also some tier component, for example, external web service. And I'm getting already a better understanding of my environment, how things are related. I can expand. And here, for example, I can see my host components on the application layer. And here I can see my Kubernetes node, and I can see the communication towards kicks from the Kubernetes, towards messaging, and towards the mainframe environment. Please ignore Bruce Wayne, Clark Kent, and Peter Parker on this view. I could mark them as a trash, but for now, for this example, they're of course not part of our real application, even though it thinks we are on distribute. Good. This is another one for our database here. And I have another Node.js application which I could use. For the ease of this presentation, I will create another special attribute for these, make it simple. So app messaging, that would be my mediation tier. And more mediation. And some more mediation. And again, I'm doing this step manual. You can create attribute rules saying once, for example, I have a certain agent name attribute, or you can predefine it on the agent side, then it would automatically set this attribute for you. And it seems I lost no application here. Save. Okay, I'm still waiting for the grouping to apply. So we have distributed environment, and for some reason the tier is current. Oh, the tier didn't work. Okay, that's what I thought. Mediation. That's already mediation. Now it's partly working. I probably forgot one of these. And it takes a while to refresh and update the map. And one last one, our messaging component should be also in the mediation here. And that will probably update in a minute. So now I can organize inside out what I want to see first, what I want to see second, and how I want to have these groups organized. And as you can see in this example, I already combined some parts very well, so you get a good understanding about the environment and consider the huge map we had before. Now it's grouped, easy readable, and how to organize. So before I finish this session, I want to show you the last example, how to glue vertexes which probably maybe even don't belong together, or only belong together maybe logically. And for this, I want to glue my IIS.net application with Peter Parker. So I go on Peter Parker. I give it a new attribute, which I call magic. And the value would be glue. And on IIS.net, I will do the same. I will give it an attribute magic, glue, and you can imagine what I do next. I add another attribute rule, and the key would be magic, save. And suddenly, you can see on the top of the screen, we have glue magic, which connects Clark Kent in the end, showing as one component. Of course, you don't want to have it on the map, something like glue magic, but you can call it an application name, a system name, a communication where you know what's behind it, and so it's showing the summary metrics. And that's very interesting. So once I click on it, I can see the hero's payment on this component, and I see below is my IIS application and is Peter Parker. So I think we solved all of the patterns, and once I expand, the components are easy digestible. I can see the individual communication items of my system ordered by web request type. And I can use as many attributes with what I want. Important is simply to keep the right order, and the order influences what to put outside and what to put inside. To see the impact on the ordering, as a very last exercise, I want to swap the tier and the environment. And for this, let's check. Once I make here the second item after the request type, the tier, and do the environment very late, meaning after the sorting on the tier, request type, and transport. You see instantly it changed completely. I have the mobile request type, web server type, host, and because my environment is one of the very last groupings, you see only after the nesting that it's inside the distributed environment. In reality, well, on this architectural view, I want to see first distributed and then host. That's why I would do it the other way around. But you can see on this example how important it is to use the right sequence on your map. And as a short summary, we can see different communication types. That's definitely one best practice. Organized by infrastructure attribute, organized by, for example, resource attributes in Kubernetes. And this is our way how we make the map digestible, how we get easily a dynamic dashboard, and how to work with superheroes. So in case you want to hear more about the map, what's connected with it, maybe want to discuss some best practices, let us know. And thank you for your interest, and thank you for watching.